Hello everybody, this is Pete from PA Labs, and today we're going to pick on Chapter 7, the first half, and this is video 4, so I guess this will be a 4.1 or 4A, and we got some big concepts to go through today. Excuse me. And the first one is structures. Up to now, everything we've defined has been a single value, a single entity. All of our variables are either true, false, or a binary, or a Boolean, or an integer, the number 5, the number 50, a float, maybe the 1.23, or a string, which would be a name, something in quotes, okay? So now we're going to define things that are much larger. It's going to encompass many individual data pieces that all relate back to a single thing. Now, the way we define this is a structure. So a structure is a series of related elements in which, as a group, define a single record or a single thing. Okay, you can think of it as a row in a spreadsheet. Each column of the spreadsheet has all these different values and whatnot, but as a group, that whole line is a structure, and it is the structure is the definition of it. The actual row is referred to as a record. Okay, so we have many structure examples in the shoot 'em up series of that I did a while back. That's a whole series that shows you how to do a side scroller. Well, actually, it's vertical. Shoot 'em up, where you got all the enemy ships coming down at you and bullets flying everywhere, and you can move around and shoot them, and it just keeps getting faster and harder and more enemies and that sort of thing. Okay, so there's many these examples in this sheet here, our code sheet, are going to be pulled from there. Another name for a structure, and this you will see in the manual and in people's normal conversation, and you've heard me say it, but I'm going to point it out so you get a better grasp. It's called a type, okay? A user-defined type. So it's not defined by Pure Basic. It's not defined by Microsoft. You're creating these yourselves, and these are user-defined types. Now, I want to go a little bit into the language of things, because language is important, and you will hear lots of phrases as you go through in programming. And I'm really bad with it. I use objects and instantiation, and I want to go and explain how that all kind of works. So a type is it's a definition or a blueprint of how to build something, okay? A thing. I don't care if it's a player ship, a bullet, it could be a house, it could be a user, it could be, a class like you're going to school and you have many classes that you go to. So class would have teacher and students and all of this sort of thing, but it's the definition of that, all right? It's a blueprint. That's the best way I can say to do it. It is not an object. A structure is not an object. An object is the instantiation of that blueprint. The instantiation means the definition. So the creation of an object. So this is a type. The minute I come down here and say define, if I could type, it would be awesome. Okay, and let's say player. And we're going to say that's our variable name, and it's going to be of type player ship. Okay, so this instantiates this. This is the definition. This is the creation. Define player. Player is the instantiated object of type player ship. You've heard me reference that a lot. I've always said a name, for instance. If I define a name of type string, okay, age of type integer, all right, those same thing. These are defined, these are referred to as primaries. They are defined by the pure basic and the language itself. They define those. We don't have to define those. That's why it stays in a different color. But we are defining this type, thus user-defined type. And the interesting and cool thing is, now when I come down here and type player, okay, a player of type player ship, I hit a backslash. Now I can fill in any of these values now associated to player. So we can say, I didn't give him a name. I should have given him a name. Sorry. Let's come up here and say name. We'll give a name of type string. We'll come down here, and now I have name. Okay? So, and we can say this equals some sort of the Millennium Falcon. Okay. Okay. So that is structures. All right. Now, we're going to get to inheritance, and we're going to get to structures defining fields inside them of structures. We will get there. That's tomorrow's lecture, not today's. So this is an important concept. It kind of blows your mind that a single thing now can take on many, many, many fields, all right? And all we refer to it as is player. And I get to all of the elements of the player ship by using the backslash, and then the software will then give me the options of all of these up here, all right? So I have a couple more examples down here. This doesn't actually run anything. So what we are going to do is move to the next one now. This is one in which we're going to say, okay, let's, much of this guy I've already discussed. This is name of, is a definition of the variable name of type string. We're going to define a structure of bullet. You may actually have many different bullets, types of bullets, thus the type index. So maybe we have a 22 caliber bullet. Maybe we have a 327 or whatever they are. I'm 9mm, that kind of thing. You may have a 3-inch artillery shell. Well, that's still a bullet, isn't it? It may be a bullet type of a laser, so it's shooting a burst of energy, photon torpedoes, but they're all just bullets, right? Or of type bullet. Another biggie in naming. Structures are individuals. They're singular. It is not a bunch of bullets. This defines a singular bullet. When you create an array, you would then say bullets plural, because an array has many individual records of bullet. Okay? So, naming conventions are very important, and it's always best to get this correct from the onset. Okay? So, if you see, I've instantiated the variable Moab of type bullet. So that's the mother of all bombs of type bullet, which would be accurate. And then we come down here, and I'm going to throw in that we have max bullets, plural, and this would normally be set to, I don't know, 50 or something. You can have 50 bullets on the screen. So each game we're going to dimension our array of type bullet, and we're going to say he's the size of our max bullets. Normally, and the last example in this series goes into a bullet moving. So it's beginnings of what's going to be animation and how things iterate in code, and you can move things in code. Okay, so we're going to come down here, and I'm going to define my game bullet array 0, because that's what I've defined is just 1. So we have 0, and I have Moab. Is it alive? No. Putting in some values. And then we can come down to the bottom of this, and this will print. This is just information, and then we will print bullet, and then we will print the name of our bullet. So if we had 50 of these, it would scroll 50 lines and spit out all the names. So this is just building on top of all the stuff you've had to date. It just expands it enormously. Let me scroll that up nice and big. And just to make sure you guys know what I'm doing, I'm holding the control key and rolling the mouse wheel, and it just zooms the whole thing. So you can see we have bullets, the bunch of dashes, and then we have bullet name equals, and then we have Moab. Okay, so that is that example. So now we're going to get to the first of the book examples. Let's see. He's doing the same thing as what I did there, except this time we're doing it in a graphic screen. We define a ship. We're going to, let's see. He's going to read the data coming off of the data section down here. He's going to read 2 names, so he's going to create 2 ships, and this is the ship spec data, each one. This first one matches here, the second one matches there. Okay, so that's what he's doing here. He's loading up this, and then he's going to say, okay, press any key to quit. And that's his code. So let's go ahead and hit F5 and let it run. And so I don't have the ability to do anything to this. Oop, crap. I shouldn't have hit that. I hit a button. Okay, sorry, I can't make any of this bigger. But here's our 2 names, our 2 ships, and the values associated. Okay. So that's basically his first example, just without working your way through it all, just kind of really spits that at you. All right, now, in the next piece of code that we have to get to is program timing. In the day of the book was written, we had a thing called a screen, graphic screen, and it was singular. It wasn't this film strip that we're using, the double window definitions, the graphic window inside the window, and the whole looping thing. Think back to the example where I put the counter in the loop, and we had like 6,000 loops counted in about 8 to 10 seconds. So if a bullet was moving in each loop, you would hit fire, and before your finger can come off the key, it will have gone across the screen and been gone. Okay, so we have to have a way to slow the thing down. Now, we're not really slowing the computer down. What we're doing is timing and slowing the process loop to say, hey, you're still running at, I don't know, 600 frames a second, 60 frames a second. But every 300 milliseconds, I want you to display my image. So it would count 300 milliseconds, and then it would display it again and again and again. Okay, so that's the concept here. So here we're going to use a timer and then a timeout value, and we're going to use a function called elapsed milliseconds. Now, when every time you hit play on a Pure Basic application, actually in most applications, most computer languages have something similar to this. Everybody has the same problem. So the computer starts counting milliseconds from the instant you hit play, and is counting milliseconds as a continuous count until he gets to you close your application. All right. So what we do is we tap into that and we say, hey, we're going to set a timer and say this is just going to hold the value of elapsed milliseconds, and when milliseconds gets to be greater than timer plus our timeout, then we'll print something. Okay, so that way you're running at full speed, 60, 120 frames a second, whatever it is, and we print here, and then we wait, and then every 300 milliseconds we print again. Now, we have some issues that we got to deal with. So anyhow, I'm getting ahead of myself. Some other values that I'm using are these enumerated values. These are, think of them as programming helpers that are part of the Pure Basic language. Pound CRLF $ is a carriage return, that's CR, and line feed LF. So these are, you can reference them individually or you can reference them together. And basically it's like hitting a carriage return at the end of something that you've printed. Otherwise you're going to print, and then it's going to continue to print, and then it's going to continue to print. It'll go, we're going to come across here, we're going to print this. If I put in a carriage return, it would be what? We would go there and it would be a carriage return, right? So this actually goes along and it prints something, and then it gets to that carriage return at the end of the line, and it goes to the next line. So carriage return returns the cursor to row 1. A line feed jumps it to here. So carriage return line feed literally does this. He moves the cursor back to there and then moves down. Okay, so I'm splitting the video here. So as always, thanks for watching.